Welcome back. Today we're going to talk about how to solve two-step equations, and I'm going to be going over 4 examples today. So how do we solve two-step equations? We want to apply the inverse operations using the reverse order. So first we want to undo addition and subtraction, then undo multiplication and division, then undo exponents, then undo brackets where applicable. In these particular situations for the examples I'll be going through today, it'll just be a matter of doing addition or subtraction first and then doing multiplication or division. Because I think a lot of where the confusion comes in with two-step equations is what should we do first? There's two things to do, and does the order matter? And my answer to that is yes, the order does matter, and we should do addition and subtraction undoing first, and then the undoing of the multiplication or the division. So without further ado, let's actually get into the examples here and how we would solve them. So the first one is 4x plus 7 is equal to 23. So there's two reasons why we don't know what x is right now, right? And the first one is this 4, and the second one is the 7. We don't want these here. We would like an equation that goes x equals blah, blah, right? Whatever x equals, because we want to find x. So how do we do that? Well, first we need to undo any addition or subtraction. So first we must get rid of this plus 7. Now, how do we get rid of a plus 7? We subtract 7. So I'm going to be subtracting 7 from both sides. If we do that, on the left side, I just have 4x. On the right side, I would have 23 minus 7, which is 16. So now that I've done my first step, I'm left with just a one-step equation of 4x is equal to 16. In order to get rid of the 4 in the 4x, I need to divide by 4, right? What's the opposite of multiplying 4 by x? Well, dividing by 4. So I'm going to divide by 4. And if I divide by 4, then these cancel out, and we just have x, and that's equal to 16 over 4. And 16 over 4 is 4. So therefore, the answer is x is equal to 4. Then let's try example B, and feel free to, by the way, to leave any questions you might have about any of this in the comment section. So for this one, for B, there's two reasons why we don't know what x is. First of all, we have this negative 5 that's multiplied by x, and then we have this plus 1. So as we know, we must undo addition and subtraction before we undo multiplication or division. So the first thing I'll do is undo the plus 1 by subtracting 1. If I subtract 1, on my left, I have just negative 5x because the plus 1 and minus 1 cancel out, which is why we're doing this, right? To get rid of the plus 1. And then negative 39 minus yet another 1 is going to be negative 40. And now, once again, I'm left with just a one-step equation. To solve the one-step equation of negative 5x is equal to negative 40, I need to get rid of the 5x. What's the opposite of multiplying x by negative 5? Well, that's going to be by dividing by negative 5. So I'll be dividing by negative 5. On my left, both of these negative 5s will cancel, so we just have x on the left. On the right, we have negative 40 divided by negative 5. And recall that if we divide two negative numbers, we end up with a positive result. So the result here is actually going to be positive 8, because 40 divided by 5 in general is 8. And the fact that they're both negative 40 and negative 5, just means our result will be positive. So positive 8 as opposed to negative 8 or a different value. All right, I have two more examples on this next page here that we'll also work through. The first one is 6y plus 4 is equal to 11. So once again, we must start by combating any addition or subtraction that's on our left. So since we have 6y plus 4, in order to get rid of the plus 4, we must subtract 4. So I'm going to do that. I'll be subtracting 4 from both sides. And if I do that, I'm going to get 6y is equal to 7, because plus 4 minus 4 cancels. And then 11 minus 4 is 7. Then I'm going to divide both sides by 6, so that these 6's will cancel out, and I get that y is equal to 7 over 6. Now, 7 over 6 is a number that's just a little bit more than 1. It's between 1 and 2, and we can't actually simplify this further. So if we're unable to simplify this further, we can just leave it as is. And that is a point I want to get across today, is that it is possible when doing two-step equations in a lot of circumstances to get a fraction or a decimal. We're not necessarily always going to get a nice round number. There might be some word problems where it would only make sense to actually get a nice round number, but when we're just solving these equations without any word problem or any context, it's certainly possible to get a fraction or a decimal as your final answer. That does not mean you have done it incorrectly just because you've gotten a fraction or decimal. Let's try example B. Negative 8y minus 10 is equal to positive 13. So first thing I want to do to my left is I would like to get rid of the minus 10. I'm going to get rid of it by adding 10 to both sides. If I do that, the minus 10 plus 10 cancel, and we get negative 8y is equal to 23. Then, in order to get rid of the negative 8 with the negative 8 times y, I'm going to divide negative 8 in both sides. And then I get on my left that these cancel, and on my right, I get negative 23 over 8. And 8 does not evenly go into 23, nor do these numbers have any common factors or anything like that other than 1. And so the final answer is just y is equal to negative 23 over 8. So yet again, we have another situation where the final answer is not a nice round number, where the final answer is actually a fraction. As always, if you have any questions, feel free to put those in the comment section, and we'll see you for the next one.